We are going to learn about correlation. Last week we did total and subtotal, and we also did totals. And what we want to cover today are two more functionalities in Excel, and this correlation and linear regression. As we do this, we are going to have the functions that we are running. We are going to look at the functions that it has. If they don't have this, we are going to add them. So now, when we talk about correlate, we are basically talking about trying to look at the relationship. There is some noise in the background.
I have muted the person.
Relationship. There is some noise in the background.
I have muted the person.
Okay. So what we are going to learn today is about correlation. And you can see here that correlation is a statistical measure. It is something that you calculate. And in most cases, the intention is to look at how strongly are two variables related. Okay. So in terms of relation, how are they related? Are they related in terms of strongly or not? And just allow me to look this my door. No disturbance. This my door so that there's no disturbance. Okay, thank you for that. So what I was saying is that we look at the relationship between two values, and when we look at this relationship between the two values, it gives us the extent to which those particular values are related. Okay, and in most cases, correlation is a statistical measure which is numeric. So and always when you are trying to get a relationship, the correlation between two variables, okay. So between -1 on the lower side and positive 1 on the upper side. Now it might fall anywhere in between. 0 will also be a value between -1 and +1. Then you may have something, for example, 0.5.
Sir, you're not sharing your screen.
Then you can also have...
Sir, you're not sharing your screen.
Oh, sorry. Yes, let me share it. Sorry, I thought I shared. Oh, sorry. Yeah, I think you are seeing my screen now. Are you seeing my screen now?
Yes.
Okay, fine. Sorry. Yes. Yeah, I think you can now see. Okay, so what I was trying to say here, I was trying to explain actually this slide. And we are saying that correlation is a statistical measure. And the intention here is to see if these particular values are related. Now, and I'm going to use an example. Let me open my Excel file. Okay. Now, this is my Excel file. Now, what happens is that let me use an example which is from the business field. Then we can know what we are trying to explain. Now, supposing I have two variables. One of the variables is, for example, I'm looking at the cost of an item. Okay. We have the demand. Okay. We have the demand for an item, and then we have the cost. Yeah, we have these two variables. Now, and within these two variables here, I have data, right? So I have, for example, I may have, let me say a particular product is on demand, and I put the demand on a scale of 1 to 10, where 1 means high demand. Okay, so let me have this. Sorry, this one should be low demand. When I score it low like that, we have low demand. Then 10, it means maybe we have high demand. Okay, so I have these two. When something is rated 10, that means it's on a high demand. Then when it is rated 1, it's on a low demand. Is 900. Okay, the demand is 10 on very high demand. And maybe the cost is 2,000. You may have let me have about 5. Let me have another. Okay. Now, if you look at this two, we have for a product. Okay, is giving the cost of that product. So this is paired data. It has been paired so that we have this our the question that we may ask ourselves is demand relating to cost. Are they related? Are these two variables? For us to be able to get that relation, we compute what we call the correlation index. And the correlation index is actually giving us the extent to which how strongly two variables are related. So this word here, strongly. So it means that when you have a value which is close to 1, that particular value that you can compute, that index that you compute will be a value between -1 and +1. So meaning that what you could have, you can have values like this. These are examples of the indexes we may have. Remember, we said on the lower side we have -1. Then on the higher side we have +1. So any number in between here, any number in between here. Like, for example, I may have a number like 5, 6. 0.56 is between +1 and -1. You may also have another number, say, for example, minus 0.92. So you see, this 0.9 value $0.99. Okay, you see 0.99. All the values that fall, all the values. Okay, so when we talk about to get the relationship between, is that it's just like having variable demand as x and this other y. You see, I can just disagree like that. We have x and y. So x, which is demand, and then y, which is the cost. So we have formula here. So we have this formula here. Actually, what you compute is what we call the Pearson correlation coefficient. Okay, because Pearson is the statistician who came up with this particular statistic or this particular measure. Now, this R is the correlation coefficient. When you are manipulating those numbers, what happens of the product of x and y? So now you can see here, this component, the product. Now in this case, you can see here, my xi will be getting the product 4 times 1200, then 5 times 2000, like that, 8 times sum. Then you sum whatever you get. So you get the product of this, you get the product of that, you get the product of that. At the end of it, you sum all of them. So here, what this one means is that you take x and you multiply by y, you get the product. Once you have the product, now this simple here means you sum. So you sum that. And then once you sum, you multiply now this by n. N is what we call the sum. If I was to number these numbers, so one of this is 4 to 1200. Then data point number 2 is 5. So it means that the value of n will be 5. And therefore here, then we have you get to subtract this other component of the formula is you get the summation of y alone, then you get the product. Okay, And then you divide that by, you have within this brackets here, we have all the values of x, okay? You square 4, you square 5, square 10, and so on like that. And once you've done that, you subtract the square of the summation. So you sum first before you square. Here you square first before you sum. But here you sum first, then you square. Now for this part, it will be the variable x, or the variable demand for that matter. Then on the right side, we have y squared minus y squared summation minus summation of y, then square. So this is the second variable. And then you multiply again by n. Our n is 5, 5. So by doing that, you'll be able to get the Pearson correlation coefficient. But of course, the formula that we have in Excel will be able to do this, without looking at this, seeing this formula. It does it in the background. Okay. Now, so as I said, this value of correlation coefficient is a value which can, and of course, what will happen is that in terms of interpreting, like for example, what I have here, when we talk about minus 0.99, what does it mean? Okay. On the other hand, when we talk about 0.99, what does it mean? Because this is positive, this is negative. Now, what it means is, first of all, the higher the value, it means this correlation is very strong. So what you will have, you can have this one here is getting closer to -1. In fact, let me have it on this other side. Okay. Let me have it on this other side. And so you can see here that on this scale, minus 0.99 is close to -1. And 0.99, which is now positive because it doesn't have any sign, it means it's very close to 1. So anything that goes towards +1 means that there is a very strong positive correlation. Okay. Now, on the other hand, minus 0.99, it means that there is a very high negative correlation. Now, what is the difference between negative correlation and positive correlation? Now, what it means here, when you look at these values that we've just shared here, now you will find that there's a trend. Sometimes you might find that when this value is increasing, when probably the demand is increasing, the cost is also increasing. So when you have a positive correlation, what it means is that when one variable is increasing, the other one is also increasing. Okay, so when one value is increasing, the other one is to have a positive correlation, Now, but when we have a situation where one variable is increasing and the other one is reducing, then it means we are going to have a a negative correlation. And a very good example will be demonstrated here. You can be able to see here. Let me go here. So you can see here that we have these patterns here. You can see I have the variable x here and the variable y. which we have depicted in a graph in a coordinate. Now, when you look at this, if I was to plot those values on a coordinate system, you will find these values here, they are just scattered. There is no pattern. There's no pattern. Even this one here, there's no pattern. There's no pattern here, there's no pattern here. And for this kind of data, it means that the value, the correlation index, the value of R is close to 0. It's either 0 or very close to 0. And when it so happens like that, what it means is that you are going to interpret that as having no correlation. Now let me use this data here. Let me use this data here. I can work with these values to compute the correlation. And how I'm going to compute the correlation is I'll use the formula here, the inbuilt function. I'll have the equal sign, then I have core. You can see correl here. Correl is for the coefficient between two data sets. So I can select that. So you can see here that it will require an array 1 and an array 2. So this one is array 1. This one is array 1. This one here. And then you are going to have the array 2, which is this one here. Okay. And I close that. In fact, what happens here is that just a minute. I have that. We have closed that. If you look at this one is going to compute the correlation, and you can see that we only require 2 arrays. This one in blue is the first array, which we have selected is from here up to here. Now you can also select plus the heading. Like for example, I would have here, instead of having this, I can have I can select including that, like that, as the first array. Then I can have the second array after a comma, so I can have that like that. Okay. So once I have that, when I press enter, you can see it gives a value, and that particular value is lying between 0.748. So you can see this value is lying between +1 and -1, and it's very strong. You see, it is very strong because 0.74. If you look at what I was saying here, 0.74 is tending towards +1. Actually, it will be somewhere here. It will be somewhere here. 0.7. It's 0.7 what? 0.748. Yeah, 0.748, like that. So you can see here that this value is positive and it is tending towards +1, and therefore this is a very strong correlation. So from this data set here that we have done, the correlation is 0.74, and it means that it's a very strong correlation, meaning that when demand increases, the cost is also increasing. That's why we have positive. So in this graph here, you can see here that this one here, if you look at this pattern here, you can see that when this value increases, the other one is also increasing, and therefore, if you was to draw the baseline of it, it will move like that. Okay, it will move like that. And this one means what? There is a positive correlation. It's a positive correlation here. okay, as opposed to what we have here. So you can see here that the values are just scattered. It is not giving any pattern, and therefore there is no correlation. And when there is no correlation, then the value R is actually 0. It is 0, or it is the value that you get is as close as possible to 0, maybe 0.001, or 0.02. That one is very close to 0.0, and therefore there's no correlation. But in a situation where you have a negative correlation, you can see here that if I was to draw a line would move down like this, meaning that when the X value is increasing, then the Y value is reducing. And therefore, we are going to have a negative correlation. Okay, we have a negative correlation. Then, of course, what we have, as we have seen in the practicals there, that we use this word correl, or for correlation, and the arguments that we are going to have inside there is array 1, and we are going to have array 2. Okay, so array 1 and array 2 you select just the way we have selected the cells there. So sometimes when you select including the headings, some versions will tell you to if the first cell is a heading or is a label. Okay, yeah, you can see here, if I have the same formula, and I select here only, okay, then I have a comma, then I have the other one, okay, then I close that. You can see this giving me the same value. This one here is simply selecting the values only, and this one here is selecting including the labels up there. So it's able to tell automatically what it does. But in some versions of Excel, it is going to prompt you to separate, to indicate whether the first cells are the labels. Okay, so you can see how you correlation is taken like that, and once you invoke this formula here, you are actually trying, what the application is going to do, it's going to compute from this formula here. Actually, it's going to manipulate and give you the value R, as we have been able to see. So when you represent that using the coordinate system, you can see that this one has a pattern, but when one variable is increasing, when the X variable is increasing, the other one is reducing. So we are going to have a negative variable. But when one or both of them are increasing, then we are going to have a positive correlation. So this is the arguments that you are going to have, and the arguments here are basically referencing the array. This is the array 1, and then this one is going to be the array 2. Okay, so we're going to have that. Now we have another correlation that we normally do, and this one is what we call Spearman's rank correlation. Now instead of correlating the actual values, you can be able to see here, instead of correlating the actual values that we just the way we've done, it's going to rank these values, and it's also going to rank this one. So what you do, if I have these values, for example, the smallest value here is 4, so I can rank it as 1. I can rank this one as number 1, and then the next value is 5, so I can rank this number 2. Then I have number 8 is the next number in that hierarchy. Then I'm going to have number 3. Then this one is going to be number 4. This is going to be number 5. Okay. Now when I can rank them also. 900 is the smallest, so I can rank that one 1. Then I rank the next number here is 1200, so I have 2. Then 1200, then 1500. So I have this one 3. I rank them. So, and 2000, that is number 4. Then I have this one 5. So now what happens here, the other correlation that I'll obtain is I simply correlate the ranks. I correlate the rank. So I correlate this and that one here. This is the rank for variable X. This one is the rank for variable Y. And that's why we talk about Spearman's rank correlation. So Spearman's rank correlation is another type of correlation. So instead of correlating the values where you are going to have Pearson correlation, you correlate the rank. You correlate the ranks just the way we've done, and you're going to have Pearson, we are going to have Spearman's rank correlation. I can just equate that so that I have this. So then I'm going to relate demand, which is X there, and then we have Y. So I'll basically use the same formula here. Equal sign, correlate, and then I'm going to select that. You have a comma, then I select that an array, then I close that brackets there. So you can see the 0.8. So when you compute, this one here is the Pearson correlation coefficient, and this one is Spearman's rank correlation. So you can see they are not far from each other. Okay, yeah, so far from each other. So what happens is correlation is basically straightforward, and for this value here, you can say the correlation is very strong. It is very strong because that value is tending towards +1. So it is positively correlated, but very strong. Any value more than 0.5, you can have it as strong. Okay, but it tends towards 0, then there is no correlation. So that's all about correlation. You will practice. I have some data here that I'm going to share. Let me see if I have I'm going to share this data here. And this one here is basically getting the correlation between X and Y. And X is the number of police officers on duty, and then the number of markings that occur. Is there a relationship between X and Y? In other words, the question that we are asking here is there any correlation between the number of police on duty and the number of markings that happen? Okay, so once you compute the correlation coefficient, then you'll be able to see whether there is a very strong correlation or not. So I want you you'll use this one here to practice how you can be able to calculate correlation. Now, the other function that I wanted us to look at today is the linear regression. This one is related to the correlation. And in the first case, when we are dealing with correlation, there are only two values. We are not sure which one is the dependent variable, which one is the independent. But in linear regression, dependent variable, dv, and then the other one is the independent variable iv. So we have the independent variable, then we have the dependent variable. And linear regression is just about a model. Okay, it's a model that how much of one variable is contributing to on the this variable x and y. X is normally the independent variable. We normally designate x as the independent variable, and y is the dependent variable. And sometimes you've seen an equation. There is normally an equation which models align. You may have seen this, and this is from 2 maths. We have y is equals to, let me have again, y is equals to mx plus c. Now, this is an equation which I think you may have come across. Actually, this is from 2-work. This is an equation which models a line, a straight line. Actually, this is a straight line. Straight line. The equation of a straight line. Okay. Straight line. And what happens in this equation is that this y here is actually the, I want to use a small y. Y is actually the dependent variable, okay? Because it means that when you are computing y, the value of y, you have to bring in the value of x, which is actually the dependent the independent variable, okay? Now, this m here is the is normally what we call the gradient, or sometimes we talk about the slope, okay? And then this c is where that particular line is intercepting the y-axis. So in linear regression, to see how is the variable x relating to the variable y, okay? Why? Because these values are there, like m is the gradient, the slope of that particular line. You can imagine a line which has been drawn from, yeah, I don't know if you can, I'll be able to share this. Let me see. Let me use Paint. Now, let me just have a draft of that. Yeah, I can have this. I hope I'll be able to draw this. Now, this is x. Don't worry about that. I have x and y. Now, this is the y-axis. Sorry. This is y, and then this is x-axis. Okay, I hope I'm able to. My mouse is a little bit not accurate, so I have x. Let me just have x like that. Now, when you have a line which goes like that, okay, it's a line. Now you'll find that this line here, the equation is given by that particular model that we've talked about here, y is equals to mx plus c. Now the line, this particular line, has what? It has the x values on it. Maybe you have another value here. You have another value here. You have another value here. Okay. So we have, for every value of x, here, we have the value y here. Okay. So what happens here is that when you are modeling, the slope of this line is basically changing y, sorry, over changing x. Okay. So this is actually the slope. And that is this value here, which is m. Okay. So now regression actually tries to to model that particular line. And when it models, it's going to give you how the independent variable is relating to the dependent variable. Okay. So you'll find here that when you have values like this, maybe I can remove the others like that. Let me remove all this. Let me remove this like that. So what we are going to have is, if you are to plot these values on the coordinate system, so that x is on the x-axis, then y is on the y-axis, then you're going to have the plots. And once you have the plots, then you can have the baseline of it, and that baseline of it has an equation, which is the model. Okay, so regression is another statistic which is giving how much the independent variable is explaining the dependent variable. Okay, and that's why, as we'll be able to see shortly, we are going to have values a value called r square. We have a value called r square, and that particular value called r square will basically give us how much that particular independent variable is contributing to the dependent variable. Okay. Now we will use the same example. Let me go here. And we are going to look at this. So we are saying that, of course, the linear regression is a statistical method which we use to find the relationship between two variables. And we have the dependent variable, then we have the independent variable, the x and y. And what happens is that when you are conducting this in Excel, you will basically have what? You will basically use the word linear regression. Okay. If you can be able to see, I don't know which version you are using, but here I can have function, then I can type here regression, then go. So you can see here, am I getting the regression here? Now, yes, I'm reminded by something. Now, I don't know which version you are running. I want you to confirm from your application of Excel whether you have this text menu here called data, because I think this here, data, click data, and then you look at whether you have this data analysis. So you click data, then I want you to check if you have this one here, data analysis, because it's under this. Analysis. Okay. So a minute. Now I hope you're able to see this one here. This regression, the regression is under data analysis. So you must have this. When you click data, text menu up here, you should be able to see data analysis. If you don't have this, then it means you need to activate, you need to update that particular version of Excel. Now, I think for me to demonstrate this one effectively, I'll request that you check if you have the data analysis, this button here, by basically clicking on data and then check on data analysis. And if you have it, maybe from the charts, you can type 1 if you have it. Type yes if you have it. Type no if you don't have. I can just take that poll so that we know how we will move forward. Yeah, most of us here don't have that. Okay. That's about how many of us? 1, 2, 3, 4, 5, 6. Now, I want to give you a procedure of activating that. And first of all, let me just demonstrate. Let me just demonstrate that maybe the remaining time we can use to have that. Now, what happens is, first of all, you must have this tool here. And let me just share this. Let me just share this on the chats, on the WhatsApp. I'm trying to send this. Let me share this. Yeah, Newton has installed that. Okay. Now, I've just shared some image on the screen, and that one will tell you how you are going to do that. Now, what we are going to do is, what you will do is you will use the add-on. Let me go that here. Yes, this is what I wanted to show you. Now, what happens is that for you to be able to access the data analysis tool, what you will do is you will go to file. You will go to file, and then you go to options. Go to options, and in options, what you will do, you will get this window here. And what you are going to do is you will select add-ins. Add-ins will allow you to add that particular functionality. So you click add-ins. Once you click add-ins, then you will click here. You can see down here we have manage add-ins, So we have Excel add-ins, and here you will click proceed. You click go, and then you will select. There are some options here, and what I want you to select is you will select the analysis tool pack. We have the analysis tool pack, so you'll select this one here. In your Excel, you will select this one here, analysis toolbar. You select this, and then you click OK. So once you click OK, it's going to add this. It's going to add this data analysis. So it means what we do it faster.
After we get into add-in, what do we add?
What you do is you click here, file, then you go to options, right?
Yeah.
Then under this menu here, you'll see add-ins. So you click add-ins.
Yeah.
And then this is manage add-ins. Then you click go, and then now you make sure this one is ticked. You see this one here, analysis toolpack.
Yeah.
Yeah. So you can make sure that this one is checked, and then you click OK. We can have some, how many minutes to do it? 3 minutes.
I'm done.
Oh, it's already there.
Yeah.
Okay, thank you. What about the rest? Most of us need not have it. Let me. Paul, have you succeeded? We have Paul, we have Newton, we have Esther, Dan, Celine.
Not yet.
Celine is done, okay. John. John is done, correct. John is done. Now, if you are, when you are done, you just say done so that it can inform me to proceed. Newton, okay, that's done. Celine done, yes. I'm waiting for the others to tell me. And as you do that, maybe I can type this. Let me type this. I want us to use this data here to demonstrate. I want us to use this one here. So we have this. Esther, you need to click on home. Sorry, not home, data. You click on data so that you'll be able to see. Click on data so that you'll be able to see.
Excuse me, Ruben. What are we adding in?
You are trying to add the data analysis tool that is going to give us the functionality for regression.
There's not.
I hope you are getting that.
There's data analysis tool pack.
Yes, that one, that one.
And there's data analysis tool pack VBA. So I have two here.
I think the first one.
Oh, tool pack. Okay.
Yes.
Then we go.
Then you click go, yes. Proceed.
Then here we have ChemDraw for Excel. Okay, I have other functions here. I have ChemDraw Excel. I have Euro currency tools. I have analysis tool pack. I click
Yes,
that
that one.
analysis tool pack. Then okay, isn't it? That's okay.
Yes, yes.
Now I'm done. I think it's okay.
Is there anybody with a problem? Esther, have you seen it? Esther?
Once I'm asking, once you have added, do you see it? Because this one I've added and I can't see it on the toolbars that are here. I don't know.
Have you selected data? This
Oh, it is in the
one here.
data. Okay.
Yes,
Ah,
let's
yeah,
select that data.
I see. It's there.
So you can see now, eh?
Yeah, yes, I can see it.
Okay, fine. Let me proceed to illustrate how we can be able to do that. Now I'll use the same data. Let me use the same data that we had used so that we will have that. Now, so what we said is when we talk about correlation, it is basically looking at the relationship between two set of values, and it merely gives us the strength, it gives us the strength of the relationship. But now linear regression is going to give us a little bit more information. It's going to give us more information, and the additional information that it gives us is how much the independent variable is explaining. Like, for example, here we can say, how much is the price? I mean, how much is the demand explaining the price of that particular product? So you can see that we have to do modeling between these two sets of data so that at the end of the day, we will be able not only to know the relationship, the correlation between the two sets, but we are going to have additional information of what variation is it giving to the independent variable. Or, put it in other words, what to what extent does it explains the independent variable? So the dependent variable. The independent variable is explaining the dependent variable, but how much? And this one leads us now to a statistic which we call R square. R square is just a square of the correlation. It's just a square of the correlation. And I'm going to demonstrate now this. So what I will do is, let me put it this one this way, so that we have this one X, then we have this one Y. This is Y. Now, this is why I'm putting this is because it's like the cost is dictating the demand. The demand is dictating the cost. That's what I want to say. The demand is dictating the cost. Sometimes when there's a lot of demand for transport, right? People are traveling for festivities, and the vehicles that we normally use, it is in very high demand. So it means the cost is going to go high. Okay. So now we want to see how much the demand is explaining the cost. And that's what linear regression is going to do. So what you do with the function that you've just installed, you will just locate it from the data analysis. So you will basically click data analysis, okay? And in this particular dialog box here, or dialog window, you are going to select regression. Regression. Then you click here, okay. Now, the moment I click regression, the regression module is going to be activated, okay? And that activation now will prompt us to input the Y range. The Y range is basically this one here, the cost. So what I will do is I'm going to select my range here. I'll basically drag this, or I simply type the reference. Okay. It is easier to drag this, so I can simply drag like that, and then I release the button. So you can see here it's selecting C2 through C7. So you can see here C2 through C7. So you can see that. Now then the next box or text box is we are going to input the X range. The X range now is the independent variable. So we select that as well, like that, by dragging. So it is selecting B2 through B7. So we have B7 there. Okay. Then now, because these first two are the labels, so we are going to exclude that. So you can do that by clicking here, label, so that you check on that. There's some chart here. If you want to see, Paul, if you want to see, you click on the data. Then you'll be able to see that analysis. You should be able to find, so long as you added it from the toolbar, you should be able to see. Okay. Now, so I was explaining that. So you check on the labels so that it eliminates this. It does not include this the first row. So this one will be designated as the labels, right? Now, once you've done that, of course, there are other functionalities that you would want to do. Like, for example, it has the line of fit plots, it has the residual plots, it has the residuals, it has the standardized residuals. All those are other functionalities which will enable us to see that. Now, it also has what we call the confidence level. We'll discuss that. But I want us to demonstrate linear regression, so I click OK. Once you are done, you click OK. Now, the moment you click OK, you will get a lot of calculations here. We have some summary output here. And our area of interest will be, you can see this value here. This is actually the correlation. You see this R. This R here, let me enlarge that. Now you can see that this is the regression statistics, and it starts with this R. This R is actually the correlation which we calculated before. Okay, that's the correlation. Now, when you look at the second statistic there, it is R square. R square is basically squaring the correlation. When you square the correlation, you get the R square. And R square is actually what we want in this output here. Okay. Now, you can be able to see here that we have 0.5608. R square, what it tells us is that the independent variable explains 56% of the dependent variable. Okay. So 0.56, when you multiply by 100, you will get 56%, meaning that the cost, the cost, I mean the demand explains up to 56% of the cost. Okay, I hope you are getting that. Yes. So Diana is saying he's not seeing that. Diana, can you unmute and tell me if you have done the add in correctly?
Yes.
You've done it correctly.
Yes.
Are you seeing a new menu called data? Data here.
Yes, I can see it.
So when you click that one, you should be able to see that analysis then. Or if you cannot be able to see, you can restart. You can restart your application. You can restart.
Okay, thank you.
Yeah. Anybody else who has not even who has not seen it, you can restart.
Okay.
You should be able to pick
Okay,
up.
thank you.
Okay. So that's what we have. You can see here when you square this value, when you square this one, let me try to square it. We see when you take that, squaring a value, use what? Use we have this symbol here. You can have square. Square. No, this is square root. Sorry. I can square this by using this symbol here. This symbol here, then 2. That means square. So you can click that. So you can see when I square, it comes to that value, which is this one here. Okay, don't worry about the adjusted R and the standard error. We will come to that when we'll be doing the statistical part. So we will have 56%. So what does this mean? It means that the demand for the demand for the product or the demand for the service is explaining 56% to the cost of the cost, 56% of the cost. Okay. So that's what it means. And when you go down there, you can see here, I want to leave this table first of ANOVA, but I want to explain this other table. We have this part of the coefficients. Now, in this part of the coefficient, this is now what will enable us to develop the equation. Okay. And you can see here that I'm going to have an equation which looks like this. Remember our first equation was y is equals to mx plus c. Mx plus c.
You're breaking.
Oh, sorry, I'm breaking, eh?
Yeah.
Hello. Okay. Okay, let me come back again. Let me explain the same thing. Now, the values that we will be interested here in is what we call the intercept. You can see here the intercept. The intercept here is 5.97. Okay. And the variable x, which is demand, is 238.059. Okay. Now, in this equation here, we are now going to have an equation. And this equation will be like this. We have this. You remember this one here? Now, remember we said for the straight line now, this value c, is going to be equal to, you remember this intercept that we've talked about? We have this intercept which is 5.97. So we are going to have this value c, actually should be small c, is this 5.97. So that will be the value of c in this equation here. Then the value of y. So we're going to have this equation. The model of that particular line will be like this. We'll have y is equals to mx. Our x here now is what? Is the demand. Okay. So we're going to have you take this, and we have demand. And then you now add the C, which is, we are going to have what? We are going to have the constant. C is the constant, sorry. C is the constant. So we are going to have 5 points plus, so we'll have plus 5.97. So you can see here, what we have here is we have this is the coefficient for demand. This is the coefficient for demand. This is the coefficient for I mean, this is the intercept. This one is the intercept, which is actually the constant. So this equation will be like this. Will be y is equals to 5.97 plus, I can just have this one on this other side, because this will be a constant, and then plus, so we are going to have 238. We'll have 238.059, and then now you multiply that. Now, what this equation here means now is that it is relating y and x. This is actually x. This demand here is actually x. It's just x like that. So we are relating the independent variable, which is x, with the dependent variable, which is y, and this model is going to govern that particular equation, meaning that when you have values on the plot, then whenever you substitute the value of x, then you're going to have the value of y, and those values are the ones which are defined by that particular line. Okay. Now this is an example of what we call simple regression. Simple. Of course, we have multiple regression. Regression because we only have two variables here. We have the dependent variable and we have the independent variable. Okay, we have the dependent variable and the independent variable. But in a situation where so many variables are explaining the independent variable, I mean the dependent variable, then we are going to have so many variables, and therefore we are going to model what we call the multiple regression. We're going to have the multiple regression, where now all the other factors will be taken in the equation. We'll have x1 for demand, maybe x2 for another variable, x3 for another variable. Okay. So what we have done here is we have actually computed this value, which is very critical, and we have also tried to come up with the equation. And when you are coming up with the equation, you simply use the coefficients. So we have the coefficient for the demand, we have the coefficient which is a constant, or what we call the intercept. Okay. So
let me ask, how did you arrive here? I didn't. I think that step must have missed it.
Are we go to these tables here?
Yes, I didn't copy the table so that I can do it along with you. So I don't know how it.
Okay, fine. Let me demonstrate again. I'll give you time to practice. Now, what I did was, you remember we had this data here.
Yeah.
Dan, are you with me?
I'm with you.
Yeah, we had this.
I just want.
We had this data.
Capture it.
Okay.
Yeah.
So it's just basically running the regression, and when we are running the regression, you'll basically do what? You'll basically click on data, then you come to data analysis, which I believe you have.
I now have data analysis.
You have it,
But how you got here is when
Okay, so when you
I
click that analysis, you will select regression. Remember here you can do a lot of you can even do correlation that we talked about. You can also do regression, you can also do moving averages and so forth. So you will see basically come here, click regression, and then you click OK, right? Now, once you click and you get this dialog window.
Are you showing on the window? I'm not seeing. Sorry about it.
You're not seeing it?
Yes.
Are you seeing my screen first? You're seeing my screen?
Seeing. Yes, I'm seeing. Where did you click to get the regression?
Okay, fine.
Yeah.
So now you basically you are on the Excel, then you click data analysis, right?
Oh yes. Okay.
And then now you can see now here that we have regression. You can see it here.
Yeah, that's okay.
And then you click OK, right? So once you click OK,
yeah.
On this part here, you will. Okay, my internet is unstable. Hope it will. Okay, so we have the first one here. You are going to select the input Y range, which is now Y range is this one here.
Yeah.
See this one
here.
Okay. You select that. You select by dragging. Then you now come again and you select the input Y range. So this one here, you select also that.
That's now X.
Then once you have selected yes. Then now I clicked label because I included all this. So to show that this is the label that we have for that particular data set, right?
All right.
So and then you click OK, and then now you'll be able to get those values.
All right.
Okay. So the first table here, will be able to give us the regression statistics, and we are saying what is very important here is the R square. Actually, this one is the correlation, and then this one is the R square. R square, this one now means we will have 56% being explained by 56%. What it means here, actually 56.1, because we have around 8 there. So 56.1% of the cost is explained by the demand. That's what it means. Okay.
There is just a minute. Sorry about. There's nothing else apart from selecting the range. These things like level, confidence. You don't put anything else. Now you just go to OK. There are
so many other options.
Yes. Do you pick any option or just leave for those can be? Yeah.
You are interested in getting the other. Now, so importantly, what I again that here that we have the number of observations. Of course, in our data we had 5 observations. 1, 2, 3, 4, 5. So this, are you seeing this 5 where it's coming from? The number of observations is 5. If there are 10 observations, you'll be able to see that. Okay. Now, then there's the table of ANOVA, which I don't want to explain because I'll explain it when we come to, when we come to comparing values. ANOVA is normally used to compare 2 sets of data. Okay, but it computes alongside regression. So, but it has no meaning here. Then that table here is very important. This is what now gives us the equation. That gives us the equation, and you will be able to see that I've picked this value. I've picked this value called the intercept. The intercept sometimes is called a constant. In some analytical tools, it's called a constant. And then we have the coefficient for the independent variable, which you have this value here. Don't worry about the other ones. The other ones we will explain. These ones are confidence labels that we may not need now, but we are interested here. So when you will now be making the equation, remember, as I started, I talked about this relationship here between y and x, the independent variable and the whatever relationship they have is described by this line, and this line is actually what I talked about here, this equation. So you can see in this equation here that for you to be able to get any value of y, then you need a value of, like now when you take this value, this is when you take 4 and 1200 and you substitute, you will see they will equate. The equation will be, it is going to fit in the equation. X for, 4 for 4 and 1200. When you substitute in this equation here, we have y will be 1200. Is it 1200? Yeah, 1200. And then this x here is going to be 4. Then you do that, then you will see it is fitting. Okay, meaning that the relationship between this and that is this equation here. The interest that we normally have in regression, when we do regression analysis, is we are interested in the model. You know, the model which is relating the independent variable with the dependent variable. Okay, and that's why we look at R and R square. And in fact, when you select those other options that that Dan talked about, was it Dan who talked about the other relations? When you select the, when you select, for example, I can select to have the line fit plots. You see this one here. It is going to give me a graph somehow. Let me see what it would give me. So you can see that when I select line of fit, you can see how the values are. So you can see there's a line which goes like this. If I'm not, there's some line which moves up, like that. And you can see the orange values are what? They are the cost. And then we have y, the blue is the cost. Okay. Now you can see that if you are to put a line there, when the demand is increasing, then the cost is increasing, and you're going to have a line, like that. Meaning that for this simple regression, you are going to have a line, and that particular line is actually the one that we have talked about here. Okay. Yeah, so that is it about regression. I've talked about regression. Of course, I know in other analytical tools, they are different. So this is the procedure of how to do that. This is the procedure for how to load that particular function. Then you have that, correct? We have selecting. Yeah, we have that. This is what I'm going to have you work with. You work with the number of the police officers and the number of markings. You are going to use this data, X and Y, and then calculate the correlation, and you also compute the regression and come up with the equation. Okay. Yeah, this is also the line of fit. You should be able to see that. This was the output that we talked about, R square. I know you should be able to come up with those particular values. And this one here is the general form of the equation. And that's why we talk about the model. We have y is equals to the constant. We have a constant here. The one that we talked about, the intercept. Okay. Then beta 1 here is the value. Beta 1 here is the value. Then this one is the independent variable, plus an error. So in sample data, you are not going to have this error here. Okay. So this is the ANOVA table. I don't want to explain this now. I'll explain that one when we come to that. Yes, thank you very much. I covered what I wanted to cover today. I want to believe that all of us have seen and you can now practice. So I'm going to share this data here. Okay. I'm going to share this data so that you can key in, and once you key in, you should be able to calculate the correlation and the regression. Now let me receive comments from you.
Okay, maybe I have a question. Can
Yes.
you kindly repeat how you do the line of is it that
Yeah.
line or that yeah.
Okay. That one is still the same procedure. It's only that the options that you select. What you do is simply, we had this one here. This was the data. So you will click data analysis. Is that okay, Celine? Data analysis. Yes. Then you select regression. Then you click OK. Now, when you are here, remember you can select more options there. You have more options here, and you can see.
I've seen it.
You see this one here.
Yeah, I've seen it.
Yeah.
Okay.
You can even have the normal probability plots, and then when you click OK, you should be able to have. I see I already have the normal plot there. Okay. Now let me receive comments from you. And I'm going to, we have about 20 minutes to go. And I finished what I was trying to explain. So yeah, let me have some comments from class, and let me start from, let me unshare. Is there any problem first of all? Any problem? Okay. Now, let me stop sharing. Okay. So let me receive some comments from you, then I think we will be good to go. I'll share I had shared the slides, so you'll just go to slide number what?
Where did you share it? Where did you share the slide? Is it on the WhatsApp chat? Mwalimu, I'm asking, where did you share the